Good morning, my dear students. Today we are going to discussing about hierarchical clustering. So hierarchical clustering means it is a tree-based hierarchical taxonomy. How to construct hierarchical clustering based on dendrogram. So this is the simple example for dendrogram. See hierarchical level clustering example. Animal is one cluster. Under the animal cluster we have different types of animals, vertebrate and invertebrate animals. So this is the simple example to understand the hierarchical clustering. So one approach for hierarchical clustering is recursive application of a partitional clustering algorithm. So here we are going to observe hierarchical clustering and dendrograms. A hierarchical clustering on a set of objects D is a set of nested partitions of D. It is represented by a binary tree. The representation of hierarchical clustering is called as dendrograms. The root node is a cluster that contains all the data points. Each parent node is a cluster made of two subclusters, children's. Each leaf node represents one data point, singleton, that is cluster with only one item. So a hierarchical clustering scheme is also called a taxonomy. In data clustering, the binary tree is called a dendrogram. So in this particular slide, the relationship between dendrogram and hierarchical clustering. How to represent hierarchical clustering with help of dendrogram. This is the dendrogram of the hierarchical cluster. So means clustering up time by cutting the dendrogram at a desired level. Each connected component forms a cluster. Yes, this is the cutting. This is the dendrogram. This is the cutting the dendrogram at a desired level. At this level we are cutting the dendrogram. Based on this cutting, how many clusters are formed in this particular hierarchical clustering? See, mainly 4 clusters are formed. At this level, these 3 nodes are in one cluster, or data points are in one cluster. These 3 data points are in another cluster. This one only in one cluster. This data point only in one cluster. These 2 data points are in another cluster. So how many clusters formed here? 4 clusters are formed. Next, this is the example, hierarchical clustering and forming clusters. See, all of you observe. Right? This is a dendrogram. Based on this cutting, how many number of clusters are formed in this particular dendrogram? See, this is one cluster. Yes, atoms. This is one cluster. This is another cluster. This ABC in one cluster. This is cluster 1. Next, D is in another cluster. This is cluster 2. Next, FG is in another cluster. That is, this is FG cluster. Right? Next, hierarchical cluster. in hierarchical clustering algorithm, in hierarchical clustering technique, mainly we have two types of algorithms. One is agglomerative clustering technique, and another one is divisive technique. The another name for agglomerative technique is called as bottom-up approach. Divisive is a top-down approach. With the help of these two techniques, build a tree from the input set S. Right? Based on these two techniques, number of not require the number of cluster k in advance. See, all of you observe. Let us assume x1, x2, x3, x4, x5, x6 are the data points, given data points. Based on these data points, how agglomerative clustering is working and how divisive clustering is working. So agglomerative clustering is nothing but it is a bottom-up approach. At bottom level, each data point acts as the cluster. Based on single link technique, x1, x2 merge together. Next level, x1, x2, x3 merge together. This side, x4, x5 merge together. Next, x4, x5, x6 merge together. At this level, x1, x2, x3 and x4, x5, x6 are merged together. Finally, this is the cluster. Right? Based on divisive approach, first of all, you have to take the entire cluster. Now the entire cluster decomposed into two another clusters. So once again, this cluster is decomposed into two clusters. Same fashion, this cluster is also decomposed into two clusters. Once again, this cluster is decomposed into two clusters. Or this is called divisive clustering, means top-down approach. Next, hierarchical agglomerative clustering (HC) algorithm. Assume a similarity function for determining the similarity of two instances. Start with all instances in a separate cluster and then repeatedly joins the two clusters that are most similar until there is only one cluster. Okay. So next, classification of AHC. We can distinguish AHC algorithm according to the type of distance measures used. There are two approaches, graph approach and geometric approach. So single link method, complete link method, these are the very, very important methods. Next, cluster distance measures. So mainly we have four types of cluster distance measures. Here we are mentioning only three things. One is single link. Single link technique means, see, this is one cluster, this is another cluster, this is another cluster. So these two are, see, distance between closest elements in the clusters. See, these two are closest to each other, so that's why we are finding, we are applying single link is mainly depending upon distance between closest elements in clusters, that is called single link. Means the minimum distance considered in single link. So complete link in the sense we are considering the maximum distance. Means the distance between farthest elements in clusters, that is called complete link. This is one cluster. This is another cluster. These two points are having the maximum farthest distance. This next one is centroids. Distance between centroids of two clusters. Okay. This is single link cluster. single link clustering. This is a dendrogram. For this particular dendrogram, we are preparing the nested clusters. See, for this particular dendrogram, this is one. For this dendrogram, this is one cluster. 3, 6 are in first cluster. Next 2, 5 are in another cluster. This is second cluster. Next 4, 3, 6, 2, 5 are in another cluster. That is fourth cluster. In third cluster, we have these 4 elements in one cluster. Means 3, 6 and 2, 5 are in one cluster. That is this one. The third cluster. Fourth cluster is 4 and 3, 6, 2, 5 are in one cluster. Next, fifth cluster, 1, all are in one cluster. That is nested clusters. This is single link clustering. This is another example, single link method. This is the dendrogram. This is the clustering points in XY plane. Based on this particular dendrogram, AB are in one cluster. In similar fashion, next JK, here we have a link, means group together, so means JK is in one cluster. Same fashion, we have to construct clouds, means not clouds, what is clusters, right? All of you observe. Anyway, I will send this particular PPT through your Google Classroom. Okay. Yes, now all of you observe. At this level, see, finally the dendrogram look like this. At this level, see, all these are in, all these are in one cluster. G is in another cluster. G is in another cluster. Next, I is only in one another cluster. L is only in one cluster. Next, remaining all are in this particular cluster. Like next, see, F is also in another cluster. F is also in another cluster. Right? Next. This is the single link method. This is the practical example, numerical example. Yes, now let us assume in XY plane we have 5 points. These are the 5 points: x1 1, 2, x2 1, 2.5, x3 3, 1, x4 4, 0.5, x5 4, 2. This is the dissimilarity matrix for the given data point. First of all, we have to calculate the dissimilarity matrix, and based on equivalent distances. How to calculate the equivalent distance? If we have 2 points in xy plane, p x1, y1, q x2, y2, what is the distance between p q? Root over x1 minus x2 whole square plus root over, means root over x1 minus x2 whole square plus y1 minus y2 whole square. This is the formula, root over x1 minus x2 whole square plus y1 minus y2 whole square. This is the equivalent distance formula. Based on this equivalent distance formula, we have to fill all those fields. So first of all, we have to prepare the matrix. Yes, right? Yes. After preparing this particular matrix, see what is the distance? What is the minimum distance between x1 and x2? Between x1 and x2, what is the distance? Minimum distance 0.5, 0.5. So now we are going to merge x1 and x2. So after merging x1 and x2, next we have to prepare the matrix like this. Means x1, x2, x3, x4, x5, x1, x2, x3, x4, x5. Yes, now we fill all these fields based on this particular formula. Means x1, x2, x3, x1, x2, x4, x1, x2, x5. So minimum distance of means minimum of x1, x3, minimum means distance between x1, x3, distance between x2, x3. So minimum of these two distance is assigned to this one, right? So now calculate the minimum distances. So what is the minimum distance? x1, x3 is 2.24. Alage x2, x3 2.5. Which one is the minimum distance? 2.24 is the minimum distance. In similar fashion, 3.35, 3 are the minimum distances. So like that you have to fill 2.24, 3.35, 3. Like 2.24, 3.35, 3. Okay. All remaining values copied from the previous. All remaining values are copied from previous matrix. Yes, after filling this particular matrix, now observe what is the minimum distance. 1.12 is the minimum distance. 1.12 is the minimum distance. So now we have to merge x3 and x4. Merge x3 and x4. After merging x3 and x4, the matrix look like this. Means x1, x2, x3, x4, x5. x1, x2, x3, x4, x5. Means x1, x2, x3, x4. This equal to minimum of this one. So which is equal to this one. Okay. Next to x3, x4, x5. x3, x4, x5 means minimum of x3, x5, x4, x5. So now we have to calculate those values. This value is 2.24. This value is 1.41. 2.24. This is 3. 2.24. This is 3. Means already you know x1, x2, x5. x1, x2, x5, this is minimum 3, so that's why you have to fill it 3 here, so 3 here. The remaining values copied from the previous matrix. So in previous matrix, so these are the values from previous matrix, copied from the previous matrix. After filling those things, now what is the minimum distance? Value 1.41 is the minimum distance. Where it is x3, x4, now we have to merge x3, x4 with x5. Merge x3, x4 and x5. After merging those two things, the matrix look like this. Now fill all those fields. After filling all those fields, what is the minimum distance here? 2.24. Means finally we have to merge x1, x2 and x3, x4, x5. x5. So now dendrogram of the given now we have to construct the hierarchical clustering for the given example with the help of single link technique. With the help of single link method. So that's why finally we have to prepare the hierarchical clustering, means how to represent hierarchical clustering based on dendrogram. This is the dendrogram of the given example. Dendrogram means based on the agglomerative technique. This is a bottom up approach. See, all of you observe, this is a bottom up approach. This is a bottom up approach. This is a 0 level, 0.5 level, 1.12 level, 1.41 level, this is 2.24 level. Means these are the minimum distances. At 0 distance, all these are in individual clusters, all are at individual clusters. Next level, 0.5 level, who are merging, the distance between these two are same and minimum, so that's why we have to merge these two data points, means these two are in same cluster. Next level, 1.12 level, means the distance between, this is very very important, the distance between x3 x4 are minimum, the value is 1.12, so that's why we have to measure these two. Means in this particular cluster x3 x4 are data points. At this level, means 1.41 level, who are merging, x3 x4 and x5 are merging, these two are merging, right? At 2.24 level, who are merging, x1 x2 merge with x3 x4 x5. Finally this is the cluster. Like that we have to prepare the hierarchical cluster based on the agglomerative technique with the help of single link method. So complete link is also another method. So in this particular slide you have the problem. So all of you observe complete link method also. In complete link we are considering the maximum distances. Instead of minimum, we are considering the maximum distances. If you have any questions, write the questions at discussion session.